Organic student taking this course. Today we are going to venture into chapter 4, which is introduction of alcohol. Actually, this slide that I prepare is actually a summary of the lecture note which we're going to be share with you tomorrow that contain or consists all the important concept that you need to know regarding this chapter. So in this chapter, we will start looking at organic molecule that incorporate CO bonds. Oxygen, which is in the group 6A of the periodic table, and in most of its compound contain two single bond and two lone pair, or one double bond and two lone pair, and is sp3 hybridized with a band molecular shape. The alcohol, phenol, and ether functional group are found in a number of important naturally occurring molecules. This is the chemical structure of ethanol, diethyl ether, methanol, and also cholesterol. Alcohol. The hydroxyl group or OH is found in alcohol and phenol functional group. Note that not the same as hydroxide OH negative, which is ionic. In alcohol, a hydroxy group is connected to a carbon atom, whereas in phenol, the OH group is connected to a benzene ring. The parent molecule of this class is also named as phenol, which can be represented as PHOH or C6H5NOH. When two carbon groups are connected by single bond to an oxygen, this is classified as the ether functional group. This is an example structure of alcohol, phenol, and also ether. The word alcohol comes from the Arabic term alcohol, meaning the fine powder. Originally, this referred to an antimony sulfide Sb2S3 compound used for eyeshadow, which was grown up to form a fine powder, but then later came to refer to any finely divided powder. In the Middle Ages, this term came to mean the essence of anything. When the Europeans took up alchemy in Middle Ages, they referred to vapor from evaporating or boiling compound as spirits, since they did not believe them to be materials in the same sense that solid and liquid were. Alchemists began referring to spirit of wine, and since an alcohol when it boils away seems to powder away to nothing, they also began to refer to alcohol of wine and then simply alcohol. This is some common example of alcohol: methanol, ethanol, 1-propanol, and 2-propanol. Methanol is also known as methyl alcohol or wood alcohol. Methyl referring to wine, while hal referring to wood. Found in wood smoke, contribute to the bouquet of new wine, metabolize in the body to form formaldehyde and formic acid, and can cause blindness or death. So methanol is one considered as a hazardous chemical. Ethanol, which is represented by CH3CH2OH, is also known as ethyl alcohol or grain alcohol. The alcohol of alcoholic beverage, the fermentation of honey, grain, or fruit juices to yield beers and wine was probably the first chemical reaction to be discovered. Ethanol metabolized in the body to produce acetaldehyde. 2-propanol, also known as isopropyl alcohol, which is used as rubbing alcohol that consists 70% isopropyl alcohol and 30% water. 2-propanol normally used as a disinfectant. Nomenclature of alcohol and phenol. Step 1. Name the longest chain to which the hydroxyl OH group is attached. The name for this chain is obtained by dropping the final E from the name of hydrocarbon parent name and adding the ending OL or OL. Step 2. Number the longest chain to give the lowest possible number to the carbon bearing the hydroxy group. Step 3. Locate the position of the hydroxy group by the number of the C to which it is attached. Step number 4 in nomenclature of alcohol and phenol is to locate and name any other substituent. Then we venture into step 5, in which you need to combine the name and location for other group, the hydroxy group location, and the longest chain into the final name. If there is more than one OH group, a counting prefix, di, tri, tetra, etc. is placed immediately in front of the suffix ol, diol, triol, or tetrol, and etc. Usually, the final E of the parent hydrocarbon is not dropped. Example 1,2-propanediol. The position of each alcohol group is indicated by carbon number separated by commas. Example 1, 3 butanediol. For cyclic alcohol, the carbon bearing the OH is numbered as 1. Phenol are named after the parent compound phenol. The C bearing the OH is numbered as 1. So you need to remember, for naming of a phenol, the C bearing the OH is always numbered as 1. Alcohol are classified into 3, which is primary, secondary, or tertiary, according to how many carbon atoms are attached to the carbon bearing the OH group. This is the structure of primary alcohol, the structure of secondary alcohol, and the structure of tertiary alcohol. The number of hydrogen on the carbon bearing the OH group does not affect some chemical properties. Physical properties of alcohol. Hydrogen bonding. The oxygen-hydrogen bond is an especially polar bond because oxygen is much more electronegative than hydrogen is. This is an example of hydrogen bonding between oxygen and hydrogen. The OH bond is therefore a polar bond, and any molecule which contains an OH bond, like an alcohol, is a polar molecule. Physical properties of alcohol. The general rule in solubility is light dissolve light. Since the OH group makes alcohol polar, they will mix with polar solvent like water, as long as the carbon chain is fairly short. This is the rule. And then the longer the carbon chain, the less soluble the alcohol is. So meaning that once the carbon chain is getting longer for an alcohol, it will become less soluble in water. This is an example of solubility of between butanol and pentanol. You can see the solubility increases and decreases with increase of long chain and short chain of the chemical compound. Hydrogen bonding of alcohol. Alcohol hydrogen bond to water. Alcohol also hydrogen bond to each other, which is being represented by this structure. Boiling point of alcohol. Because alcohol hydrogen bond to each other, they have higher boiling point than alkane on the same molecular weight. The boiling point of alcohol increases as the molecule become larger, which can be shown in the example in the table below. Propane have been represented by structure CH3, CH2, and CH3, which molecular weight of 44.09 have a boiling point of negative 42.1 compared to dimethyl ether having the molecular weight approximately the same. However, the boiling point is definitely higher than the boiling point of propane. The same are shown for ethanol, having almost the identical molecular weight with propanol. However, the boiling point is definitely higher, which is 78.3 compared to propane, which have a boiling point of negative 42.1 degrees Celsius. This shows that the boiling point of alcohol increases as the molecule become larger. Reaction of alcohol. Alcohol undergo dehydration to produce alkene. Heating alcohol in concentrated sulfuric acid (H2SO4) at high temperature 180 degrees Celsius will remove the OH group and a H from an adjacent carbon to produce an alkene, with water as a byproduct. Since water is removed from the alcohol, this reaction is known as dehydration reaction or an elimination reaction, which is represented by this general reaction below, in which the alcohol is being heated in a concentrated sulfuric acid at temperature of 100 degrees Celsius, producing water as the byproduct and producing alkene, which consists a double bond as the final product. If there is more than one possible product of a dehydration reaction, the major product can be predicted from the Z-shift rule. Z-shift rule notify that when an alkane is produced in an elimination reaction, the major product is the one with the more highly substituted double bond, which being shown by example below. If here alcohol is being heated at temperature of 100 degrees Celsius in high concentration of H2SO4 with sulfuric acid, producing 90% and 10%, a mixture of between two compounds, and then it will produce the byproduct of water. Alcohol also undergoes dehydration to produce ether. Heating alcohol in concentrated sulfuric acid at temperature of 140 degrees Celsius remove a molecule of water from two alcohol molecules, causing the R group to become attached to an oxygen atom, forming an ether functional group. This is represented by the general reaction below. You can see here two alcohol is being heated at high temperature of 140 degrees Celsius in concentrated sulfuric acid will produce the final product consists of two R group and the byproduct of water. Alcohol also undergoes oxidation to produce carbonyl compound. An oxidation reaction occurs when a molecule loses electron. This is usually manifested as an increase in the number of oxygen atoms or a decrease in the number of hydrogen atoms. Some common oxidizing agents include potassium permanganate, chromic acid, sodium dichromate, and other CR6 salts. Alcohol can be oxidized by removing two hydrogen atoms from the molecule. The exact product of the reaction will depend on the type of alcohol. This reaction is being represented by the general reaction below. Primary or secondary alcohol can be oxidized to produce compound containing the carbonyl group, a carbon-oxygen double bond, C double bond A. This is an example of how primary and secondary alcohol is being oxidized to produce aldehyde or ketone. Oxidation of primary alcohol. Primary alcohol are oxidized first to aldehyde, but the aldehyde are then usually oxidized into carboxylic acid. So this show a two-step reaction to produce the final product. Okay, this is an example of ethanol, how it's being oxidized into acetaldehyde, which is type 1 or one example of aldehyde, and then the acetaldehyde will then oxidize further to to produce the final product of acetic acid, which is one type of carboxylic acid. In the body, oxidation of ethanol to acetaldehyde takes place in the liver. The acetaldehyde is further oxidized to acetyl coenzyme A, which can be used to synthesize fat or eventually be oxidized to water and carbon dioxide. Oxidation of secondary alcohol. Secondary alcohol are oxidized to ketone, which cannot be oxidized any further. Okay. Difference from primary alcohol, which underwent two type of oxidation, two step of oxidation. For secondary alcohol, it only undergoes uh, one step oxidation, producing ketone as the final product. This is an example how two propanol oxidize to produce the final product acetone. Oxidation of tertiary alcohol. Tertiary alcohol, because there is by definition no hydrogen on the alcoholic carbon, cannot be oxidized. So this is an example of tertiary alcohol, which is butyl alcohol. When once it undergoes oxidation reaction, there will be no reaction occur because there is no hydrogen on the alcoholic carbon that can be oxidized. Some important alcohol. Ethylene glycol. Ethylene glycol are being used as an antifreeze. Pure ethylene glycol freeze at 11 degree Fahrenheit, but at 50-50 mixture of ethylene glycol and water, it will freeze at temperature of negative 37 Fahrenheit. It also being used as airplane de-icer, humectant, keep other substance moist, and ethylene glycol are also being used in ballpoint pen ink. Another important alcohol is propylene glycol, which is also being used as antifreeze, moisturizer in lotion, and also food. Another important alcohol is cinnamic alcohol. Cinnamic alcohol are used in perfume, particularly in lilac and other fluorescent flavoring agent, and also being used in soap and also cosmetic. Lactic acid is also another important alcohol. It produced from fermentation of sugar during anaerobic condition. It has a sour taste. It is found in sawdust bread, pickles, saltnut sweets, and etc. This is also example of important alcohol. Propanol, which is known as pine oil, is being used in perfume, and petricide used in domestic cleaner. Another type of important alcohol is menthol. This is produced from oil of mint. It has a cooling taste, found in cough drops, shaving lotion, and methylated tobacco. Another important type of alcohol is benzyl alcohol. It is being used in perfume and flavor. It's also being used in cosmetic, ointment, ballpoint pen inks. Another type of important uh, alcohol is vitamin A, which is also known as retinol. Phenol. Phenol are usually weak acid. A solution of phenol in water, carbolic acid, can be used as an antiseptic and disinfectant. Joseph Lister introduced the use of phenol as a hospital antiseptic in 1897, which cut down drastically on death due to complications resulting from the use of unsterilized equipment. So, in 1897, phenol is already being used as an antiseptic and also disinfectant in hospital. Important phenol. Orthophenylphenol, which is main ingredient in Lysol. 2-benzyl-4-chlorophenol, which is the main ingredient in Lysol. Other phenols are also present in Lysol. They interfere with oxidation reaction to prevent the spoiling of food. 4-chloro-3,5-dimethyl phenols is being used as topical antiseptic. Another type of important phenol is 4-N-hexyl-isocyanates, which is found in mouthwash and also being used as a throat lozenge. Phenol as preservative. Butylated hydroxyanisole or BHA and BHT butylated hydroxytoluene is being used as antioxidant used in preservation of food, gasoline, lubricating oil, and rubber. Vitamin C, which is also one type of phenol, is being used as antioxidant, which prevent oxidation of lipid, red and white blood cell, polyunsaturated fatty acid, lung tissue, and also prevent oxidation in lung of pollutant such as NO2 and also O3. Phenol in flavor and fragrance. Phenol can also be found in flavor and fragrance. For example, vanillin, which can be found as the oil of vanilla. Piperine, which is also known as white and black pepper. 2-fluoryl-methanol is its odor of coffee. Pelargonidin is a flavonoid responsible for the red color of genuine ripe raspberry and also strawberry. Capsaicin is an active component of red and green chili pepper or paprika that cause the hotness of the chili pepper itself. Estradiol and also testosterone is also type of important phenol. Ether. In the ether functional group, two carbon groups are connected to a single oxygen. This example of ether. Two carbon groups are connected to a single carbon. This example CH3O CH3, two carbon connected to a single atom. This is another example CH3O CH2 CH3. We can see here two carbon atom connected to a single oxygen atom. This also is being represented by this another example. Ether nomenclature. Common names for ether are obtained by first naming the two carbon groups attached to the oxygen in alphabetical order and then adding the word ether to the end. If the two groups are the same, the prefix di is used, although sometimes this is simply dropped. For example, ethyl ether. In the UPAC system, ether are named as alkoxy substituent or OR, which is represented by alkoxy group. The YL ending of alkyl substituent is replaced by oxy. This CH3 represented by methyl. However, when oxygen is attached to the methyl group, is also known as methoxy. The same goes for ethyl. One is being attached to oxygen atom. Its name is then changed from ethyl to ethoxy. Some ether are found in cyclic structure. A ring that contains elements other than carbon is called heterocyclic ring. This example of ether found in cyclic structure: furan, tetrahydrofuran, and also pyran. Tetrahydrofuran or THF is a common solvent in organic reaction, often used in place of diethyl ether. Furan and puran turn up frequently in carbohydrate chemistry. Physical properties of ether. Alcohol hydrogen bond to each other because they have highly polar OH bond. Ether do not have the OH bond and so do not hydrogen bond to each other. For alcohol, there is a hydrogen bonding between OH in the alcohol structure. However, for ether, there is no hydrogen bonding between the OH bond. Physical properties of ether. Ether are slightly polar and can hydrogen bond to water, although very weak through the oxygen bond. So instead of forming a connection between OH, it will connect with the hydrogen bond to water through the oxygen atom. Ether therefore have low boiling point and a high solubility in water than hydrocarbon. Ether are inert to most reagents, so they make good solvent for chemical reaction. Some ether also make good anesthetic. This is a comparison, the boiling point of alcohol in comparison to ether and alkane. This here show the water solubility characteristic of alcohol in comparison to ether and alkane. Some important ether. Ethylene oxide is actually an epoxide. Meta-T-butyl ether or MTBE is a common gasoline additive used as an octane booster to oxygenate the gas and make it burn with less knocking. It has been used since 1979 as a replacement for tetraethylene or leaded gasoline. This additive is subjected to intense debate because of potential health hazard of drinking water contaminated with meta-T-butyl ether. 18 crown stick. A crown ether, which is being discovered by Charles J. Pedersen, Donald J. Cram, and also Jean Marie Line, which have been awarded with Nobel Prize in 1987. This 18 crown 6, which is capable of binding metal ion together, which is quite impressive. Anesthetic. Nitrous oxide, which is being used as a laughing gas, is the first chemical anesthetic which being discovered by Sir Humphrey Davy in 80,000. Chloroform CHCl3, which is being discovered by James Young Simpson in 1846, is the first to use as an anesthesia during childbirth. Diethyl ether, first common anesthetic discovered by Crawford W. Long in 1842, William T. G. Morton and Charles T. Jackson in 1844. Divinyl ether, which is a faster acting and less nauseating than diethyl ether. Thiol. Okay. Sulfur is in the same group on the periodic table as an oxygen, and so form many compounds which are similar to oxygen. This is an example the general structure of alcohol, thiol, and also disulfide. Many thiol have strong unpleasant odor. Ethanediol, for instance, is added to a natural gas to make it possible to detect gas leak. This is the chemical structure of ethanediol, CH3CH2SH. A few interesting thiol. Propanediol, okay, is produced when onions are cut. Alkyl and also allyl sulfide. These compounds are partially responsible for the odor and flavor of garlic. So when you cut garlic, it will produce alkyl and also allyl sulfide. Yeah, they is responsible for the odor and flavor during the cutting of garlic. Cysteine is the amino acid is found in many proteins. The CH group can link with other CH group to form disulfide bridges. Disulfide linkage are important structural feature of some protein, especially those of hair. So it can be found as a protein in hair. Enzyme containing CH group can be damaged by complexation with heavy metal such as lead and mercury. Gas warfare, chlorine and phosgene. Chlorine and phosgene are among the first agents to have been used in gas warfare. Molecular chlorine is a gas at room temperature and heavier than air. Breathing chlorine gas causes pulmonary edema, swelling from excess fluid in tissue. Phosgene is a particularly insidious poison since symptoms may take from 1 to 3 days to appear. The gas do not have any obvious an odor as chlorine, and when inhaled, it hydrolyzes in lung to produce hydrochloric acid, which dissolves the membrane in the lung. This can result in edema, blood loss, shock, and respiratory failure. Phosgene must be inhaled to be effective, since it cannot be absorbed through the skin. Another example of Alcohol another example of chemical compound is being used in gas warfare are the mustard gas. Mustard gas is a chemical weapon first used in 1917 during the World War One at the Battle of Ypres. It has sweet, agreeable odor similar to that of mustard, but the similarity ends there. It forms painful blisters on the skin on contact and in lung when inhaled. Symptoms usually develop anywhere from 4 to 24 hours after exposure. Exposure produces deep itching or burning blister, swelling on the eyelid, and possibly blindness. Inhalation at high concentration damages the mucous membrane, causing bleeding and blistering within the lung, leading to pulmonary edema. It also carcinogenic and mutagenic, causes damage to the DNA. Mustard gas is not very soluble in water but very soluble in fat, contributing to its rapid absorption into the skin. It easily penetrates the early form of protective clothing and gas masks. Modern improvements include using longer carbon chain to make the molecule more carbon-like and thus more fat-soluble. Nitrogen mustard have nitrogen atom in place of the sulfur. Reaction of alcohol. Alcohol underwent a lot of reaction. This is an example of reaction that alcohol underwent. The first one is that dehydration of alcohol to give alkene. Alcohol are dissolved in sulfuric acid and be heated at temperature of 180 degrees Celsius to produce alkene and byproduct of water. Alcohol also dehydrate to give ether and byproduct of water. Oxidation of primary alcohol will also give aldehyde or carboxylic acid. Oxidation of secondary alcohol will produce ketone, whereas the oxidation of tertiary alcohol will produce no reaction. So this is the end of this slide. Thank you so much for listening to this slide and thank you so much for your time. So basically, like I mentioned in the previous slide, the first slide, this slide contains all the important concepts that you need to know that's been summarized from the lecture note, which we will share with you tomorrow. Have a nice day ahead to you and enjoy listening or reading to my lecture note. Have a nice